Welcome to a new episode of the MBSE Podcast. After a longer summer break, we are back and we have a very interesting guest today. It's Juozas from a company called Sensmetry, but he will introduce himself later on, afterwards. Juozas did something very cool. He and his team, he thought about building a SysML v2 tool, and he's not one of the usual suspects from the past, and he has a very different and a very promising approach how to work with SysML v2, and that's what we will hear and see afterwards here in this podcast. But before I talk too much, Juozas, please introduce yourself.
Thanks so much, Christian. A privilege to be part of the podcast and talk about SysML v2 and our product, which is open source, SysIDE. So myself, I'm a CEO of Sensmetry and one of the two founders. By training, I'm a mathematician. So I did study mathematics as undergrad and master's, then did PhD in mathematical statistics on stochastic dynamical systems. Afterwards worked in automated driving industry, working on perception algorithms and how to make them safe and reliable. And it turned out to be very difficult. So that's why the company Sensmetry has been started to address these very hard problems of creating cyber physical systems that are safety and mission critical, that are trustworthy and that we can all trust. So that's about me and about Sensmetry.
Cool. And yeah, that's the main question is actually what is your tool? And you mentioned named it SysIDE. You can see it written on your T-shirt. So people who are not familiar with it would call it SysIDE because it's the usual spelling of IDE at the end, but you call it SysIDE. Yeah, what actually is SysIDE?
So first we pronounce it as SysIDE.
SysIDE, not Sys, so C.
And SysIDE, as everyone knows what it is. It's the beach, and it's very typically comfortable and very enjoyable, and that's exactly the aspiration what we try to achieve with SysML v2 modeling for our tool SysIDE. Of course, it's a nice play on pronunciation, which has two meanings. SysIDE for Systems Integrated Developer Environment, providing the specific the explanation what it truly does, and SysIDE to get this feel how it should feel, and that's what we're trying to achieve. So if very briefly in a nutshell, SysIDE is a SysML v2 editing environment, providing the rich textual SysML v2 editing modeling support that a modern day developer expects, the language support for a modern programming language. So we all know who worked with some software engineering languages that these days writing software is very different than it was 20 years ago or so. And this is thanks to very powerful integrated developer environments that check errors for us, provide hints how to complete different syntactical structures and so on. So this is what SysIDE provides, is making systems modeling a lot easier, and making the models that systems engineers produce a lot more quality. In addition, SysIDE is also something to be used for machines, that it's essentially a SysML v2 model analysis system that parses and analyzes the model, and it can be used by computers and automated workflows to extract information from SysML v2 models and a lot more. But we can tell later about this.
Yeah, before that, please give us a little bit of background. How does someone come up or wake up in the morning and say, yeah, we are building a SysML v2 tool? So what was the motivation? What was the starting point behind your tool?
So I have to step back a little bit and go back in time a little bit. And this goes back to my introduction. I'm a mathematician, and I worked in automated driving industry, right at the height, responsible for developing, the automated driving software and what people call these days AI algorithms for the next generation of automated driving vehicles. And the system is very, very complex and involves a lot of things. But the systems we want to create really trustworthy systems where we talk about small probabilities, and then we can, make sure that the small probability events not happen. So to talk about small probability events and talk about these in a proper way that not only mathematicians can understand, but engineers across the enterprise can understand, we need a language. And we need a language which is not English, but a language which is rigorous and machine interpretable. And as a company, from the start, we've been developing these specific rigorous languages that are interpretable both by humans and machines. So, going back in the company's history, we contributed to some other DSLs, domain-specific languages in automated driving domain, defining the environment around the vehicle and so on. And as a company, our main focus has been risk analysis, assessment, and risk management, operational risk management through real-time diagnostics frameworks that producing and generating these real-time diagnostics frameworks for controlling and managing risks in complex cyber-physical systems. And for this, we needed rigorous language, what the system is, because this comes from the philosophy of the company. What we started from the start is bringing rigor and quality through making engineering more rigorous, and in doing so, bringing so much efficiency and quality gains in the process. Because by making engineering more rigorous, that not only humans can understand and computers can understand, we unlock and unleash the power of automation that's available to all of us. And we all know that in many cases now these days, we much more trust systems produced, and products produced automatically than, handcrafted, because typically they end up even, more quality, not to mention that the cost is significantly lower. So yeah, so that's the philosophy and the motivation starting from the origins and the philosophy of the company, and being very concrete, we worked on risk analysis and risk management for complex satellite application, and we need to generate thousands of diagnostics running in real time, managing different types of risks that occur in real time on a satellite constellation. And for this, we needed something that allows us to talk rigorously about what the system is, what the risks are being mitigated, and how to bring these thousands of diagnostics that need to be generated on a complex satellite in very little time and keep updating this very effectively. So this was really truly value driven and internal internal demand driven project, and we started by porting RAML to SysML v2 initially. So RAML is this risk analysis assurance standard, originally developed within SysML1. So this has been over 2 years ago, and then when in doing so, we realized there is no good tooling available in SysML v2. So that's what was the origin from SysIDE. It originally was an internal tool, and then we realized it's useful for a lot more people. So that's when we open sourced it.
So you already have a SysML v2 version of RAML then?
So,
is this correct?
Oh, yeah, we do have it internally, at least for parts of it, for quite a long time. And in the OMG Quarter 3 meeting next week, which is responsible for this, I think we can bring this to the table, that we can speed up the process of porting RAML to SysML v2 more quickly.
Of course, they have it on their agenda to transform RAML from v1 to v2, of course. Yeah. So yeah, it was, I think, you mentioned it 2 years ago, and I remember when I first saw your tool, so I was extremely surprised. I thought, wow, how crazy it is that someone implemented the whole SysML v2 during that time, 2 years ago. SysML is not published officially yet, so it was a moving target. And then someone implemented it. I first thought it must be a copy of the pilot implementation or something like that. So how did you manage to implement this this complex language, SysML v2, and compliant with the standard?
So we now have been working for this over 2 years. So, it's hard. But we put a lot of effort internally because we truly saw the value of it. And it was truly, as I mentioned, an internal motivation that we see the value of having a rigorous system specification, which enables this seamless collaboration and automation that's possible to unlock through having a rigorous, machine readable and human uniquely interpretable specification. So this arose internal need, as I mentioned. We have a lot of motivated people who believe in this vision of making systems more rigorous and more trustworthy. So that's that's how it happened. A lot of hard work.
Okay, well, okay, cool.
And I hope I don't tell too much in advance, but I tried it out. I loaded the plugin in VS Code, and it was quite interesting how easy it was. It was just installing a plugin, and the first thing that you see as a user is yes, you can use the textual notation, and you have the syntax highlighting like you had it in the pilot implementations. But for sure, it is more than syntax highlighting. So can you give us a little bit more insight what your tool can do, what it does in the background? Does it build up an object model and so on?
Yeah, so it does the basic thing within a blink of an eye that you don't mention, which is read the model, which is in some engineering terms means parsing the source code, building an internal representation of the model in another data structure that allows for different types of checks to happen within it and analyze the model. And before you notice, provide you a feedback about what's wrong with your inputs, or provides you feedback what you might want to enter next and how to autocomplete your particular SysML v2 syntax construct, or that your types are not matching, or that something is badly defined and there is some sort of mismatch. So that's what it does. It's a very clever automated agent reading very quickly your source code and analyzing it and raising all the issues that you have and suggesting what things you might want to define next. So that's how it works. And there's something that we'll mention later. We have 2 implementations of SysIDE, and one that we have been maintaining for a long time now. It's an open source project, used now around 3,000 people around the world. That's a lot of very progressive institutions, both in industry and academia. And so it gained significant traction and a lot of great feedback. Many institutions like the European Space Agency has been starting porting their methodology using SysML, using SysIDE from SysML 1 to SysML 2, and many other initiatives that that we are aware. But we also have the upcoming SysIDE Pro version, which is going to be a lot more powerful version, a lot more performant, and with a lot more features that are aimed at power users and enterprise users. And that's yet another full rework of full SysIDE implementation that's going to be released soon. And in already September, an early access program for all the early adopters is starting. So that's what SysIDE is. It has these two different branches, one open source available to all and one upcoming SysIDE Pro version.
Is there already a way how to sign up for the early adopters version?
Yes, there is. So let's just go to sensmetry.com/products, and then there is a SysIDE page, and then there is a link to early adopter registration form, and we'll get back to you.
Cool. And so you only use the textual notation of SysML v2, and if people think of systems engineering, SysML modeling and stuff, there's a strong focus on the diagrams, and I personally think it's focused too much on the diagrams. But you only use now the textual notation, which is a big change. So what are the use cases you see for the application of the pure textual notation in systems engineering projects, and what is the target group? Are these only software engineers that do systems engineering, or also the other systems engineers who are not familiar with software? There are a lot of questions in one.
We truly believe that it's both of these audiences. And there's a lot to talk about this, but first, purely textual notation focuses only on the meaning. And there is just the meaning compressed in the textual notation. In a graphical notation, there is a lot of context, added about, preferences, about colors and positioning and potential, formatting and so on. And actually just focusing on the meaning, removing all the additional things that are not part of this system allows also to zoom in and focus on just the meaning, what the system is. And we've been surprised by engaging with a lot of early adopters of SysML v2, how many of them said, I only use textual now, because it's just so much easier and quicker for me to understand what the model does, just looking at the source code. So this has been, and these are people who have been using diagrams from SysML 1 for over a decade by now, and they are very heavy users of SysML 1, and they switched to this paradigm and seeing this as a more productive way of working. The diagrams are still important because you want to share with other stakeholders, so that's a separate story. And we are not against diagrams. We truly believe that both are important and needed, but as a primary language, we believe in textual.
And do you plan to support diagrams like in the reference implementation, so that I can generate the diagrams, so not have graphical editors, but I can generate diagrams? So
that's planned as part of the SysIDE Pro version, but it's not currently available in the open source version. But we still believe in textual editing as a primary way of interacting with the system model. So that's one thing. It's a matter of getting used to it, and there is a reason. Just getting back to the software world, why graphical programming languages haven't taken the software world by storm, and that's why people are using Python, which that's from only TypeScript, JavaScript, all C++, and all these other languages. We are not replaced by graphical modeling, graphical software languages that exist, and you can express the same semantics. It just, once your systems get complex, as they do get in software, and we talk, software systems are very, very complex, and huge code bases. That's where textual notation becomes in many cases preferable.
But there's a need for in the software world to do the architecture documentation and to see the architecture of the software. No? And I think then you need the graphical view on the software.
So it's
the
useful
more
for
high-level abstract. And the same, it's in the system world.
That's correct. So that's what I mentioned. We are by no means against the graphical visualization. What we are arguing that the meaning for many users is more effectively expressed in textual notation.
Yeah, totally agree. You're much closer
especially
on the model level. If you do the diagrams, it's more just drawing things. No? And if you do text notation, you model.
That's correct. And there's also one more important reason, which is very important in the current world that we live in, which is very much in engineering, software-defined world. So most of the systems are software-defined. So, at an extreme, we can think about a car by, being wheels with electric motors and actuators, and sensors like cameras attached to it, some chassis and a big touchscreen. Everything else is software-defined, and that's been the trend, and that for quite some time now. And
a few episodes ago, we had Doug Rosenberg here as our guest, and he said, "Without software, there is no system." That's his statement.
That's correct. So what happens now is that there is the majority of the system is defined as software, and there's all these workflows that are called continuous integration, continuous deployment, or continuous delivery workflows that are allowing to update the system, the software-defined system, very quickly, going from a system specification change to the actual system change, with passing automatically a lot of tests and quality checks, and going, in many cases, as in continuous deployment case, right into production. And through textual notation with SysML v2, it allows for software engineers to become the first-class citizens, as well as at the top of the system specification in a software defined world. And that's really, really powerful. The role of systems engineers becomes a lot greater, where systems engineers control a lot of the aspects, and a lot of in the same software-defined systems world, where they adopt the same type of workflows that the majority of the organization is already using. So that's the big change. And the reality is that in the software-defined world, the majority of the organization uses software languages and software workflows, and version control systems like Git, enabled by services like GitHub, GitLab, and so on. CI/CD pipelines, continuous integration, continuous deployment, or delivery things that allow for big IT companies to push thousands of updates of the production system in a day. So that's what happens in big software companies, and this is what SysML v2 enables to achieve with software-defined systems as well, where software engineers, rather than sending a diagram, rather than sending some documents and having meetings, they create a system specification update, push it to the main branch, and then automatically a lot of things get generated, going, the different software changes that auto-generate and happening, tests run, formal verifications running, and all sorts of things that can be enabled by these CI/CD pipelines, and potentially pushing right into deployment and production, or at least a prototype that can be validated. So that's what textual enables. And then there's the same language. So something from our experience, this allows software engineers immediately to understand what the system is, because they know how to open a source code file and understand that there is a new telemetry signal has been defined, for instance, at the system model level. And the fact that I need to know a new telemetry signal about temperature is not something to be defined by a software engineer. It's a systems engineer's job, what type of physical quantities I want to monitor, and I want to know what's happening with my system, how some C++ engineer know what type of things should be defined as signals. And that's exactly what SysML v2 allows to do. In an example of a telemetry signal that needs to be generated, and for instance, monitoring some critical health feature like temperature, it's defined by a systems engineer. And then software engineers immediately know that there needs to be a particular type of signal created within a particular software language, and it can go a lot further.
I guess it gets extremely important if you have much behavior in your system model. So in former times, very often people modeled structures over structures, a little bit of a behavior. But in the software-defined world where we are going to, and in this model-based development that we will see even more in future, I guess the behavioral part gets more and more interesting. And therefore, maybe the next question, I think the model execution by testing your actions, your state machines, gets even more important than it was in SysML v1. So do you plan to support this also somehow? So kind of a debugger or whatever?
Absolutely. So that's exactly what SysIDE Pro brings. And at the end of the podcast, if you are on video, we'll show a small demo example of what it will look like. Just a small peek to cover in a very short period of time. And that's exactly what we are aiming to achieve, where SysML2 is a language, but this language needs to be executable specification. That's what we believe in. And to become an executable specification, it needs to generate a system prototype. It tries to generate a lot of code that actually controls, for instance, a particular cyber physical system. And the way to do this is for us is to connect with the established and established software world environments like Python, which is the #1 programming language and the main glue language from which so many of the systems scientific computing languages are available. So much of the statistical analysis libraries are available. So much of the simulation libraries are available, and enabled to take advantage of so many things that have been created by the community, be it open packages and models, or be it private and proprietary, and be able to connect this with the SysML v2 model and make it executable. And so for us, it's to be achieved through bindings into the most popular glue languages like Python, TypeScript, and others, depending on needs, Java, C++, that from which you can turn the SysML v2 model into an executable one. So that's the vision, and that's what we are doing with SysIDE and SysIDE Pro.
Does the Copilot work with SysIDE in Visual Studio Code?
Not yet.
Okay.
So
I tried it with another plug. I forgot the name. There's another plugin that connects ChatGPT with Visual Studio, and then I get a mix of SysIDE code completion stuff and code completion stuff from the AI. So it's a bit.
So the challenge with that is that we need a bit more of SysML v2 code bases to train this auto suggestions on, and that's
Maybe we can talk next week in Chicago about that. There's a project going on about this. Okay. Yeah, you already announced the demo, but before we go to a demo, so there are different versions. We have this open source version is already available, and you plan the pro version.
That's correct.
So can you explain the difference between the two versions and what are your future plans of SysIDE?
Absolutely. So the open source version is very important to us. We want SysML v2 and systems as code paradigm be available to all, to university students, to startups, to everyone. And that's why
by the way, I think that will be a big impact, a positive impact, of course, in the MBSE world. We do not have this in the SysML v1 world. No, it's not possible to create this creative space of hobby projects that we need, and it's not there in SysML v1. It's impossible to do that. So that's really great.
Mm-hmm. Yeah. So that's exactly why we, a true believers and really want to build the open creative community, who can imagine great things that can be achieved with SysML v2, and open in collaboration enabled by interoperability through the textual format. So that's SysIDE CE community. CE stands for the community edition. SysIDE Pro is aimed at power users and enterprise applications. So what SysIDE Pro brings is a lot more performant version of SysIDE. So SysIDE CE is good, but if you work with hundreds of thousands of lines or millions of lines of systems model in a system model, which is, we know some companies face these types of challenges. That's what SysIDE Pro allows, still works, without any notice that when this massive code base, having these hundreds of thousands of millions of lines gets all reparsed and analyzed before the human notices. So that's one thing. So we are, bringing something like 50x improvements in speed, over SysIDE CE. So that's one aspect. But the true big thing is the programmatic interface in creating the models and analyzing the models through all these bindings, Python bindings, TypeScript bindings, and so on, that enables to use SysIDE in CI/CD, continuous integration, continuous delivery, deployment workflows within organizations, and allows to go from system levels description in SysML v2 to a prototype in no time, immediately, like automatically and instantly. And that's exactly, we believe a true paradigm change is a huge game changer in systems engineering and engineering more broadly. So that's the focus of SysIDE Pro. And this, going from system specification update to a prototype generated automatically and instantly, this is something what enterprises need and want, because it requires collaboration between different teams and setting up these automatic workflows that produce a prototype from a system level specification update, and this allows to make systems a lot better, because there's this, one thing is when we can do a lot more analysis, do a lot of analysis up front in making a system better, and try to think what exactly requirements we need. That takes a lot of time, and that's very slow, and it often doesn't produce the result we want still, because we miss something. And what we believe in is how to get the time from a system specification update to a prototype to the minimal possible, which allows to explore design space in the minimal time possible, allowing to make the systems a lot better and you know and make this very efficiently and very quickly. So that's our our target, and this can be done for the functionality that SysIDE Pro brings.
Yeah. What I really like on this vision is that in former times, very often we had the case that you had nice methodologies building up your models, and then they had more documentation character. There was this media break between the SysML world and the later world, the single engineering disciplines. And I think the CI/CD idea is the ideal place to do this kind of model transformation that you need, coming from this system language to a discipline-specific language. So that's really cool if this works.
Yeah. I think SysIDE is the beginning of the next big thing in the systems engineering.
So that's what
cool.
we very much believe in, and that's why we are so excited about this.
Yeah, cool. Okay, so in respect of time, Tim, maybe you want
Let's have a look on that.
Yeah.
Yeah.
Let's do some hands-on.
That's great. So we will show a very simple toy example here to illustrate the concept of what we mean by going from a system level specification update, so a system description update within SysML v2, to a prototype automatically on the system specification update. So so that's will come later, but now that's about SysIDE Pro. We'll start first introducing SysIDE is Community Edition, which is the this integrated developer environment to work very effectively and efficiently with SysML v2 models. And so let's start from the baseline, and where you start if you just open the SysML2 file and try to work with it. That's how it looks like. It's a text file, and that's what you would get if you open it with a Notepad or equivalent basic text edit application. It's possible to work. It's a language. It's defined, and you can create SysML v2 files, but it's very difficult both to create and to understand what's happening within them. So now let's install SysIDE CE. So we are within, in this particular case, VS Codium, or equivalent to VS Code is another, equivalent IDE. So, just right from the marketplace, at the click of the button, we installed SysIDE CE. So if people have not worked and experienced working with VS Code, it's the most popular developer environment in the world now. Something over 70% of the developers use it. Software engineers use it every day. And very simply to think about it, it's a bit like a browser where you want to get your work done, and then you create the functionality for installing various type of extensions and add-ons and customizing it, and and subscribing to different services in a similar way as people use a web browser to get the job done. So that's exactly what SysIDE, how SysIDE comes alive within VS Code. Install an extension, and now it's it's becoming SysIDE interface. So immediately the code gets colored, and we have the all the different syntactical elements in different colors. Now we have two definitions here in SysML v2 for a fridge architecture. So an example is about a fridge. So we have a mechanical component and electrical component. And then we define, an electromechanical component, which inherits the properties of electromechanical and mechanical. And so here we can see, how quickly we update a cooling system, and updating, compressors being electromechanical component, evaporator and, etc. being electromechanical component. And this is done super quickly because we utilize the the functionality of the very effective editing environment. You see multi-cursor editing and immediately auto-completion. So, so that happens very quickly.
Mm-hmm.
Now on Hoover, we can immediately see the details of these different entities within the source code. So we on Hover, sorry. So that's exactly, you have all the context, what this particular variable is about, what class it belongs to, and etc. So we can also analyze and see, for instance, the source code, for tracing. But in this particular, now in the demo, now we open just the rename functionality, where we can automatically rename all this electromechanical components into something, into something different, like mechatronic. So that's this replaces, does not a stupid rename, but does restart rename, where it only renames these particular entities that have the same semantic meaning. We also have all this navigation where you can jump between and trace within the source code and see where this object is defined, and go up in the definition, in the definitions, or alternatively we can see go down and find all the other all the definitions of, if we go to the class, check which objects are of that particular class. So it allows for a human to analyze the code and quickly understand what's going on, and where this particular variable is used, or where this particular class is being used. So maybe Simon, it does a lot more. So this is very, very basic, things that we showed. For instance, if we had some syntactical error, or we had a mismatch of data types, or had something missing, then it would raise an error for us. For instance, here in this, we're just adding an example where the part was misspelled by a port, and then we immediately see an error being raised where highlighted that there is there is an issue with that something here is not correct, and explaining what is not correct, and then we can immediately fix the error immediately, because we don't need to wait for a source code to compile it. All the issues are being raised immediately as we edit the SysML v2 file. Okay, so so that's the user experience, and this very high quality user experience that SysIDE gives to developers. And this is what a modern software engineer developer would expect from an integrated developer environment.
Yeah, right.
So now we will go to peeking into SysIDE Pro, and that enables this system as code paradigm, allowing to generate a prototype, or potentially even a production system, right on the update of the system specification in the SysML v2 file. So let me explain this simple example, again a toy example that we want to illustrate this concept. We have a fridge, and as a system engineer, we want to define the functionality of the fridge. And what we in particular want to define is what happens when the temperature goes outside the target temperature that the food inside the fridge should be in so that it doesn't go bad. And in this particular example, we define the states as a green state being the state that the temperature is in the target range and the food is in a good it's in a good environment. Yellow is essentially a state where the door has been opened and the temperature is rising, and there should be some sort of warning happening as a yellow state that maybe the door should be closed. But it's still not yet a terribly warm temperature that the food is going bad quickly. And the red state, when we are outside this, we're outside the range of green and yellow, and then the food goes bad quickly, and that's where there should be really some sort of strong alert happening in informing that someone really should come and close the fridge door. So this is an example of the definition of a state machine within SysML v2, and that's what we have this defined within the SysML v2 file. Now, what we can do immediately is to trigger a code generation from SysML v2 file that immediately generates and executes the state machine through accessing the information, the definition within the SysML v2 model through Python, embedding the state machine within a state machine execution package available within Python, and running through it, simulating it on time series data representing the data, time series that would be coming from thermometer data within the fridge. So, this particular data has been, randomly generated, and then providing statistics of how much time, based on this particular test time series, the fridge has been in green state, meaning, all is good. Red meaning, really bad. There's some, the food is likely to, go off very quickly, go bad very quickly. And yellow, which we meant, we have maybe a door a little bit propped up, or the door just been opened, and this just happened, right? This has been a single click, and then we are going right from a SysML v2 specification to a system state machine execution, which in this case is running on a laptop, but in the exact similar way, we could have CI/CD pipelines set up where this would actually update the the source code on this if it's a Python thing, it would be a source code that would be interpreted on a fridge, or it could generate the embedded software that would be deployed on the fridge, and then we could immediately also get the same type of data from the real fridge.
So you did not execute the model, you transformed the model to Python, and you executed the Python code, is correct? Or is it direct model execution?
So that's what enables model execution, essentially, that the exact execution in this particular, in the background, is happening embedding the SysML v2 state machine specification into a Python state machine
got it.
Package, and then executing this immediately. But so you can do this in the same way and replicate the same way if it's not Python, if it's something else, if it's if it's another code generation framework. And this is possible, and SysML v2 has really nice constructs of particularly tagging and allowing to choose a particular way of processing the SysML v2 file with particular type of other software, to interpret it and to make it executable. So and go all the way to this now, the system prototype. So in this case, it's a virtual prototype, but you can, the same Python code can be, could be potentially immediately deployed on the real fridge. And and the example, if we go back now to the demo, now, a system engineer might, look at, now this is the histogram of how much time, is spent in different states, and might ask this question, why is spending so much time in red based on, this simulation, or maybe this, real validation based on the, on the real data. And, actually, it spends so much because the way it's defined is there is only way from go to red to green. That's the way it's been defined. And actually, there is, the system engineer might decide, we don't want this fridge to stay in the red state and maybe beep very loud for a very long time until, the temperature within the fridge goes to the target temperature as desired temperature within the desired range. Let's introduce another state, orange, which will be essentially the state going from red back to green through an orange state. And then it's just one line update within the SysML v2 find in the state machine, and it's immediately. So now here, just we are, running through this updated file with this one line update, and it's immediately auto generates and executes the state machine now, which has this orange state, and gathers exact same statistics based on the simulation about how much time it stays in different states, including the orange state. And here we see this system design improvement going from a system specification to update that immediately to essentially a validation step where we can test our design and have this system specification executable and get feedback and make an based on a prototype and how it performed essentially in no time. It's literally how you've seen within the blink of an eye, and spot the potential issues that we might miss as systems engineers, and and update them and regenerate a prototype. And this type of thing enables the system as code paradigm that we argue for, where in principle we can make systems a lot better through eliminating this time to a prototype and immediately validating and testing and going up and improving the specification again and making systems a lot better. And that's exactly what we believe in as being a super important and powerful paradigm, is being as quick from system design update to to testing a prototype, and that's what SysIDE enables. And and we can talk a lot about what could happen over the coming years. You can have CNC machines print parts in a robot assembly line, putting them together based on the same click on a button and checking and validating this again very, very quickly, and then again getting feedback about the prototype and and improving this again. So this is something that we believe is the future, and this is something that we very much excited and want to enable. And when I say prototype, it can be both, a prototype, a virtual prototype based on which we can do multi-domain optimization of our system, and it can be literally going down to a true physical prototype or a true deployment. So yeah, and that's that's what we believe is very powerful and will be a game changer in the industry.
Yeah, very cool, very impressive demonstration.
Yeah, very interesting. Yeah, cool. Thank you very much for that. Yeah, we're running out of time. I think there's a lot of stuff in that, so we could do another podcast episode in the future. maybe not so much focusing then on the tool, but more on this paradigm shift. So it's quite interesting. So yeah, and let's talk next week about that.
Absolutely. We always love to engage with everyone interested in this, and so please reach out to us, and to me personally via email. Please subscribe to our SysIDE newsletter. We have the SysIDE newsletter, providing all the news about the open source version releases and updates and where we are going with that, and as well as the SysIDE Pro. We have this early access program as well. Please subscribe to that, and and let's stay in touch, and let's create these amazing, much better and much more trustworthy and reliable systems much more quickly. So and we truly, something that we truly believe is what this brings is makes systems engineers work a lot more exciting and a lot more fun, where systems engineers focus on not parsing Excel files and doing manual checking with their eyes and trying to do these manual checks, but truly focusing on what I want my system to do, how do I want my system to behave, and how to create the best product or system possible.
Yeah, very cool. Yeah, then, well, it's after our summer break, the first episode of the summer break, and we already know the next episode. And also the episode after that, but that's still a secret. But the next episode is about product line engineering. We already had that topic, I think, half a year ago, or maybe this was already 1 year ago with Marco Follingiri. And this time our guest is Danilo Beuche from PTC. And it will be already in, let's check, in 2 weeks, almost 2 weeks, September the 19th. So then we talk about product line engineering, another interesting topic. And well, as usual, do not forget,
trust us, we are systems engineers. Goodbye.
All right, okay, thank you, bye-bye.
Bye.